This video is about classifying types of reactions, and we're going to look at 5 different examples and figure out what type of reaction is happening. So for this first one, we start with a compound, HF. A reaction happens, and it splits into 2 different things. When that happens, when you have one thing that splits into more than one thing, it's breaking down. And the word we use when an equation represents a substance that breaks down is decomposition. So when you have a reaction where you start with one thing and it breaks into smaller pieces, that's decomposition. Next example. So this one, you start with C3H8 plus 5O2 yields 3CO2 plus 4H2O. Sometimes when people look at these, they think, oh, it's single replacement because we've got this plus this yields this plus this, and oxygen comes into this single. But notice this, none of the products over here are single. None of them are on their own. If you see that, then watch out for this. Is it a hydrocarbon? So carbon and hydrogen reacting with oxygen to make CO2 and water? If so, if you are making CO2 and water from a hydrocarbon and oxygen, if that's the case, then this is a combustion reaction. So always look for, is it reacting with oxygen? Are you making CO2 and water? Probably combustion. All right, the next example, we have Na plus O2, or 2Na plus O2 yields 2Na2O. We start with 2 different things and they combine to make one compound. There's no plus sign in between them over here. They're stuck together in a chemical bond, the Na and the oxygen are. So when sodium and oxygen stick together in a chemical bond, that's been synthesized. So we call this reaction where multiple things combine to one compound, we call this synthesis. This is also called composition sometimes, so your class may use the word composition. Next one, calcium reacts with 2HBr to yield H2 plus CaBr2. Calcium Ca enters this reaction not bonded to anybody. It is alone. Hydrogen leaves this reaction, not bonded to anybody except itself. It is H2, but it's not stuck to another element. This guy enters single. This guy leaves single. So a way to think of it is calcium enters this single, kicks out the H, attaches to the Br. Now we have Ca and Br attached to each other. H is on its own. When that happens, that is single replacement. One element swoops in, not attached to anybody, kicks somebody out, then that guy is alone, other guy is attached in a compound. Now that's single replacement. Now this one, I'll go ahead and tell you, is double replacement. We start with 2 compounds, end with 2 compounds, similar to single, except look, nobody enters this alone. Lithium and carbonate are in a compound. Calcium and chloride are in a compound. We end with calcium and carbonate in a compound, lithium and chloride in a compound. Because everybody starts and ends in a compound, and you'll notice the carbonate and the chloride switched places, they kind of swapped. That's double replacement. So when you have these guys that are swapping, so carbonate and chloride switch. Now carbonates with calcium, chlorides with lithium. When you have that, that's double replacement.